Good evening, everyone. I'm Sahas.
And I'm Sheha, and welcome to the Awareness and Mentoring session of SLIIT Bashaway 2022, an automation and scripting competition hosted by the SLIIT FOSS community. We have all been very excited about the upcoming inter-university competition, which aims to bring the best of analytical and thinking skills for all the craft coders out there. To brief up today's agenda, we will first have our renowned lecturers to fill you up with the competition details and then move ahead with the mentoring session conducted by Mr. Jananath Banuka, who is a DevOps system engineer. Don't worry, we will also have a Q&A session for interested future prospects. Without further delay, I will now hand over the platform to Sahas, who will take over from here. Thank you.
Thank you, Shekhar, for that warm welcome. And now I would like to invite Dr. Nuwan Kodawal to give you an introduction to Sleek Bashaway 2022 competition.
Hello, Sahas. You can hear me, right?
Yes, sir, you are audible.
Yeah. So, good evening, everybody. So, I want to thank the SLIIT FOSS community first for inviting me to the inauguration of the awareness of SLIIT Bashway 2022 competition. And also, let me take this opportunity to warmly welcome all the participants of the Bashway 2022 competition. I believe you are here because you are passionate about coding. At least some of you might be interested about coding. That's why you might be here. So if you talk about the SLIIT FOSS community, it is a group of like-minded voluntary students who are passionate about FOSS and also about coding. So I think it's my duty to tell you a little bit about SLIIT because there might be a few of you outside SLIIT. So SLIIT is the leading non-state university in Sri Lanka. We are a complete university. So we have degrees offering from computing, engineering, business, architecture, quantity surveying, biotechnology, biosciences, physical sciences, education, mathematics, English, nursing, law, nursing, and I think I mentioned nursing before as well, and psychology. We also have a hospitality school where we teach about hospitality management. So in addition to that, we have postgraduate courses ranging from MScs to PhDs, and we work with various foreign partners, including Curtin University, Queensland University, Liverpool and John Moores University, just to name a few. So if you talk about Faculty of Computing, where most of the students of the FOSS community belong to, it is one of the largest faculties in any university in Sri Lanka. So if you take the total number of student population, both undergraduate and postgraduate, we have over 8,800 students currently. And our cadre strength, academic cadre strength is over 150 permanent cadre members. And this includes over 15 PhD holders and 6 professors. Now, coming back to this competition. So in this competition, you will work in teams, solving challenges that are thrown to you. So as the name suggests, you will have to develop automation scripts written in Bash, Python, or any other suitable language. Now, one of the main differences that I see in FOSS software and the people who work with FOSS compared to people and also commercial software, generally in people who are doing FOSS or in the FOSS community really promotes reuse. Actually, it's not that difficult, and in fact, it's easy to write a completely new piece of code that solves a particular problem. What is really challenging and what is really difficult is to develop some code that leverages on the strength of some existing code and maybe some IT solutions that are already out there. So if you look, basically looking at the Linux system itself, which is open source, if you look at the pipe command that is there in Linux, so as a power user, you can combine various Linux commands together like grep or maybe sort or maybe cat to do something useful. So generally in this FOSS community, like you kind of develop tools which can be reused for many purposes. As you know, I'm an academic and also I'm an administrator. But there are countless times where I have resorted to using scripts in Python or Bash to automate tasks. So for instance, one common instance is like maybe to take some output from one piece of software that is already there and then change the data so that it can be transformed to be input to another software. And also, like whatever the software that we have, there will be always like manual processes that we have to do, like maybe summarizing data. And once again, this the ability to write scripts in Bash or maybe Python will certainly help. I think most of us know Excel. Now that's kind of ideal for simple data manipulation. But when it comes to cleaning and processing data, if you know how to write a few scripts, you become a power user. And in fact, like you can easily develop simple solutions that will help save your time and also of your entire team that works with you. Now, the organizers of this competition hopes that this competition will promote analytical skills and problem-solving skills, which I believe it will. Now, these are very important skills today for any IT professional who wants to work in the today's agile workplace that is there. So let me congratulate the FOSS team for coming up with this exciting, innovative, and timely competition. And to our competitors, well done. You have taken the right step to develop the skill set to be useful and to be a productive professional in the IT job market when you graduate. So thank you so much. I wish all the competitors all the very best in this competition. So over to you, Sahas.
Thank you so much, Dr. Nuwan. And also to add on to that, I'd also like to give you a quick recap of what Bashaway 2022 is. This is a competition that is a challenge-driven competition where you have to develop automation scripts in Bash, Python, or Java, as Dr. Nuwan already mentioned, within a given time duration. We have custom designed questions cooked up by our own people within the club to prevent you from finding results for them online or even avoiding duplicate questions. If you have any questions regarding the competition, please feel free to drop them in the chat or reach out to us at any given time so we can clarify your doubts immediately. With that being said, now I'd like to hand over this virtual stage to Mr. Jagat Vikramaratne to speak a few words about the importance of participating in these sort of competitions. Mr. Jagat, the stage is yours.
Yes, Sahas, I think I'm audible to you.
Yes, you are, sir.
Okay. Good evening, everyone. Thank you, SLIIT FOSS committee, for inviting me for this wonderful occasion. Today we have Dr. Nuwan Kodagode, our Associate Dean in Faculty of Computing, Mr. Amila Senaratne, Head Industry Engagement Unit, Mr. Jananath Banuka, our guest speaker today, then other staff members, and dear students. Today is a very important day for us, all of us at SLIIT FOSS community. Why? We are ready to launch our brand new competition, Bashaway 2022. So, before I explain why you have to join with Bashaway, SLIIT as the largest degree awarding institute in Sri Lanka. So we are organizing many competitions for students. One main competition we organize is Code Fest. One of you can share the Code Fest URL in the chat, and others can visit. Code Fest is our own and the main competition. So separate competitions for juniors, school kids, and another separate set of competition for undergraduate students like you. So many competition. If you like design, if you like hackathons, if you like data science, data science available. So if you like network security, so for all students, you can find a specific competition for you. So our Code Fest. Then we are having many student clubs at SLIIT. So we are having MS Club, and we are having FOSS Club, one of the most active clubs in SLIIT, and I think SLIIT FOSS Club is most active FOSS club in Sri Lanka. So for each and every month, you are having various activities targeting young undergraduates. Right. Why you have to participate for this bashway? Simply, you can get lot by participating. You can sharpen all your skills. You already know you have to sharpen your technical skills, you have to sharpen and you have to develop your soft skills to ready for the industry after you graduate. So by mastering scripting language or any language, for example Python, then you can improve your technical skills. So then you can show your skills to others, your colleagues, other undergraduates, your friends in other universities and the industry. And then you will get industry standard evaluation. What else? Uh, you can easily develop your analytical skills by engaging with this type of challenge. As Dr. Nuan mentioned, your programming definitely improve. Those are few of the technical stuff you can improve, but lot. And what about the soft skills? Within the given time, you have to finish your solutions. You have to work as a group, a team working. One should be the leader, leadership skills. Then you have to get all resources. You have to integrate all the group resources. Work as a team. So you can you can improve your soft skills easily by participating Bashway 2020. Right? And another very important point. Right? Now you participate this competition as undergraduates. Some of you from SLIIT, our own students. Some of you are from government universities. Some of you are from private universities. But at one day, once you complete your degree program, you all are competing for your jobs in the industry. Right? So before that day, you can network with other friends. SLIIT students, you can network with other students in other universities. Others also, we warmly welcome you to SLIIT. So engage with our own students. So you can create a network. FOSS is always helping. Please network with all the students. Many advantages by networking. Why? If other university organizing a competition, they will invite you. If they are organizing a technical session, they are inviting you. And if you are organizing a technical session or guest speech, you are not forgetting your friends in other universities. So it's a win-win situation. So by participating for Bashway 2022, you can get a lot. So I will wish all the very best for the competitors. And I have to thank you, SLIIT, FOSS community, to organizing this. And I have to thank our guest speaker today. Okay, thank you very much. Enjoy the competition. Over to you.
Thank you so much for those kind words, especially regarding the competition and also the SLIIT for students and also our community within our university. And now to review the static site, I would like to invite Mr. Amila Senarathna to take the stage. Mr. Amila?
Audible to you, Sasha?
Yes, you are, sir.
Right. Let me share my screen. So I hope you all can see the website. So it's bashaway.slitfast.org is the URL that you're supposed to use to log to this slide. And in the login screen, you'll be able to see the timeline of the competition, registration details about the registration process, and awareness sessions. And most importantly, you will be able to see why this competition is organized and what exactly this bashaway to 2022 means. And for competitors, this will be something important. So you will be able to see rules and regulations related to the competition in the under the rules section, and also you'll be able to get updates about the speakers conducting sessions in parallel to bashaway during this competition time. So thank I hope Sasha will tell you more details about the registration process. Registration is not yet open, so he will guide you through the registration process. Thank you.
Thank you so much, sir. And yes, when it comes to registration, registration will be opening once the countdown hits zero. And again, thank you, Amila sir, for sharing the static website with us and for your time. As of right now, the registrations are not open, but again, you can go to bashaway.slitfos.org to register once the registrations will be open. That will be tomorrow. And now, to give you an insight onto automation and high-level application usage through Docker, I would like to invite Mr. Jananath Banuka, a fellow alumni and a DevOps engineer. Mr. Jananath, we are glad to have you, and now the stage is yours.
Hello, everyone. Good evening. I hope I am audible.
You are audible. Thanks
Okay,
for
great.
being with us.
Yeah. So, good evening. So, even though I can't see you, I hope everyone is safe and sound. And thank you for joining this session. As per the introduction, my name is Jananath Banuka, and I'm working as a DevOps/system engineer. And I graduated from SLIIT in 2020. And also, first of all, a big shout out to the FOSS community of SLIIT for organizing and conducting this series of sessions and inviting me for the first session of the series, which is on automation. So yeah, so let me start the slides. I think it's already been shared. Okay, so here's what we have today. So we are going to talk about the gist of the automation, as you already know, as during the introductory sessions as well. So we are going to talk about the gist of the automation because it's a very broad area and not possible to conclude into a single session. And we wanted to give you some kind of an understanding about what is automation, what was life like before the automation, and how it is now. And also, we would like to talk about the automation tools landscape in different domains, and a little bit of containerization and Docker, and also a very small hands-on at the end. Just a spoiler alert: this session is going to be a very generic and a shallow overview of the automation collectively. So don't expect anything in depth. We are just scratching the surface of a very deep subject, just to give you some understanding going forward in this series that might help you. Okay, so to the next slide, actually, yeah, let's go for it. So what is automation? So the automation, in simply the okay. So the automation is, as you can see, it's actually the process of creating software and systems to replace, repeatable processes and reduce the manual intervention. So this can be achieved with a set of tools, softwares, computer programs, or any kind of scripts. So even though the definition says it all, so I think the better way to understand this is to give you some kind of an example from the real world, so you will grasp the idea even better. So back in 2019, this is something I did during the first job after the internship, as I remember in 2019. So the company I worked, we had these several EC2 instances. So anyone who doesn't know the EC2 instances, they are just the virtual machines on the cloud, in this case, the AWS. And actually, we were using this for the testing purposes. And, there were some simple Python applications running on them. And since this is for testing purposes, these virtual machines only need to run during the testing time and shut off during the every other time, including the weekends. So we could save some cost. So the developer teams or the testing team, every time they are done with the testing, they inform us that that we are done with the testings, and we should log into the AWS console and shut down the servers. And in the next morning, when they need them back, we again have to log into the AWS console and click some few buttons and start them. So this is something our team had to do repetitively, like each and every day. I remember even there were some days we forgot to stop these instances, and it was running all the time, piling up a fortune of money, which is not a really good idea. So this needs to be stopped, and we need to come up with a solution. So we wrote a Lambda function, which is another service on the AWS. So if anyone doesn't know about Lambda function, just think of it as you can write a fragment of code using JavaScript or Python or Java, and actually you can execute in the cloud, executing it on the cloud. So that's what basically Lambda function is. And with the Lambda function and with the help of the AWS Event Bridge, which is another service, we actually set to trigger that Lambda function every day at 6 a.m. So every day it triggers at 6 a.m. in the morning to start the virtual machines. And every day at 7 p.m. In the evening, Lambda function triggers again, and it will actually stop the servers, and even on the weekends. So since then, we never had to do that manually, as the Lambda function did it for us. So like this, there are many ways we could do the same thing, but we actually use what is best for us, but by that time. And yeah, so now you get some kind of an understanding, an idea on what automation is and why it is really important, and how it can be benefit to an engineer or a company in the long run. So these are just few examples. There are so many out there. So if we look into the next slide, we have why automation. What's the usability of that? So now that we discuss about what automation is, we can look into the fact that why we need it and what we can leverage with it. So in these slides, you can see a very generic sets of pros that we can achieve with the automating tasks, and I will quickly go through it. So the first one is the cost savings, actually. So just like my previous example, with the Lambda function, the little bit of tweak that we did there, we were able to actually save a lot of money, around like 200 USD dollars. So with IT automation, few engineering hours are required to complete the same repetitive task, and automation can also increase the productivity and reduce the infrastructure costs by optimizing the resource utilization, and also decrease the cost associated with the human error. So it is not just, when you say the cost savings, it's not just the cost of tangible errors that we're having. So it's just it's also the intangible
It seems that our speaker is experiencing some technical issues related to power cuts. We will be back with you soon.
Hi all, we are experiencing a bit of technical issues, so don't worry, we'll be back. So in the meanwhile, you can check out the website Bashaway, as well as you can join our WhatsApp group, which the link will be available soon. So yeah, you can join our WhatsApp group and stay tuned with all the updates about the competition.
Hello guys, can you hear me?
Yes, sir, we can hear you.
Yeah, sorry,
Yeah.
yeah, technical
Yes, sir.
issue from.
That's fine.
So, yeah, where did you miss me?
Sir, I think it's better if you share your slides again. When the power went, I think that also went up. Yeah.
Okay, sure. Sorry for the inconvenience. So yeah, I was actually explaining this. Can you guys tell me like where did I miss?
Sir, I think it's better if you continue from this end because it lagged for quite a bit. Continue from
Okay,
this.
sure. Yeah, great. So as I mentioned, like these are the usabilities that we have on the automation, like advantages, the cost savings. Yeah, I gave you some examples on cost savings, like with the Lambda function that we wrote. It's actually real world example that we used, and with the Lambda function, we could able to uh, save a lot of money and also the time as well, because every manual work that we actually do, uh, so it is actually taking a lot of time. So by automating the most repetitive and time consuming tasks, teams can free up their time to spend on other tasks, so which is really a win-win situation for everyone. And other one is the fast operations. So with automation, we can speed up the operations by a considerable amount of time. So by reducing the service and the resource delivery times from weeks to hours. As I mentioned, like even in my first example, we had to spend a quite time, without doing our other tasks, because and it is actually time consuming. It was taking some time, even though it is just a server shut off and turning on. So but with automation, it is really faster. We can speed up the operations by very considerable amount of time. And also the product that we build, we can deploy the changes in a short amount of time, and this will actually help to welcome the new changes and ship them as fast as possible. And the other point is the reduced errors. So every time that a human intervene something, they're going to be there's a buffer time. That's actually a buffer for the human errors. So with the automation, it ensures the consistency on a larger scale, something that's impossible to do with human completing task manually. So this will reduce any potential errors a human could do. So that is something that we have, and also the better security. Regarding the security, since automation requires less human interventions to view and secure sensitive information to reduce the possibility of the breaches. So this is something actually we see day-to-day life. Like so, IT automation can be used to help the teams to act as soon as possible if there are any security vulnerability attacks or breaches. So, for example, using a monitoring and alerting solution. So we could inform the teams and actually act quickly when a security breach happens. So these are some usabilities and applications of the automation that we have. And if we go into the next slide, we let's talk about the a little bit of tools landscape in the IT automation. So so the potential applications of automations are nearly infinite, but some of the most common ones include, the cloud automation, resource provisioning, configuration management, security automation, those like that. So the cloud automation, this is automating the tasks related to the deployments on the cloud environments with tools such as, the Kubernetes, Helms, just like my example using a Lambda function. And the resource provisioning, this is basically creating, modifying, and deleting and maintaining resources on the cloud environments. And we have the configuration management. For example, if you want to install Apache or any software package on multiple servers, you don't have to go one by one and do it manually, because these tools such as Ansible, Puppet, they will do it for you once it is configured and set up. And the security automation. So this is like such as monitoring and the response. So automation can also be applied to the security areas, such as finding vulnerabilities and setting up the automatic alerts in case of a breach. So I will actually most of these areas tally with one another and use any mutual tools. For example, the cloud automation and the resource provisioning, they go in hand in hand. So we wouldn't talk about, we wouldn't actually talk much about these tools, just a few which are mostly used by everyone and everyone is interested in. So the first one is actually the Kubernetes. This is under the cloud automation. So the Kubernetes, I think everyone knows the Kubernetes. Everyone, I think, have heard about that, even though probably you haven't worked with it. So it's an open source container orchestration platform that automates many of the manual processes that we do that involve in deploying, managing, and scaling the containerized applications. So Kubernetes has three different components. Different components work in conjunction with each other to facilitate this automation process. So we have the kube masters, kube worker nodes, or we call the minions, and we have the schedulers and controllers, etcd clusters itself. So all these components actually they work in conjunction to facilitate and help this automation process. And the next tool is the Terraform. Hopefully, like most of the people here knows that. So the Terraform is one of the widely used automation tools to provision the infrastructure, mostly on the cloud environments. So actually, you can build, change, and destroy the infrastructure with the Terraform. So if you don't use any infrastructure provisioning tools, what happens is you have to manually create all the resources in the cloud. And more importantly, you have a hard time managing these resources. For example, I mean, anyone can go into AWS Console or Azure with a few clicks of a button. They can provision anything. But after some time, like months after that, so you don't know what you provisioned, you don't know what you deleted, you don't know what you managed. It is going to be a very coax situation. So in that case, Terraform has this feature called the state file, which is like it's not a database, actually it's a JSON object, which will have all the configurations, all the details about the resource that has been provisioned. So every time we need to, for example, if we can provision a virtual machine and we can provision a security group. So if there's after some time, after a while, if you want to add some changes, if we do it manually, we don't know which security group we created back then. So this is really hard to identify and hard to manage. So the Terraform will solve that problem. It has all the states in its state file, and it will be managed by the Terraform itself. And if we have anything to be modified, it will take care of it. So it's really easy and a cool tool. So there are some other cloud proprietary tools such as the CloudFormation from the AWS and Azure RM templates from the Azure. And there are some other tools that does the same thing, such as Crossplane, Pulumi, like that. And we have the Ansible. So Ansible is an open source tool that provides simple but powerful automation for the cross-platform. configuration support, because it is actually written by the Python. So it also used for the application deployment and doing some, for example, updates on the servers, and doing patches, something like that. So it also supports, now it supports the cloud provisioning. Nearly anything a system administrator does on a weekly or a daily basis, we can actually automate the same thing with Ansible. So it's a very widely populated tool. And so regarding the security automation, so security itself is a wide area. So, but sake of this session, let's focus on the container security. Just like every other type, we have the security automation. There are tens of hundreds of tools for different areas of security. Trivy is one of the famous container scan automation tools. What it does is it scans any container images for any vulnerabilities, and actually it produces a very comprehensive report with the severities, links to the CVSS scores, and any other additional details. So this helps the developers to mitigate any critical vulnerabilities, and always build and publish a more secure container image. And yeah, so this is something I want to discuss. This is an in-house solution, actually. Apart from these tools that are primarily used in the cloud environments that I previously mentioned, we can still automate things in our local environment as well. The reason I put the in-house solution is because it is something that actually we can write from scratch by ourselves. So we don't need to have any third-party tool. We don't have to rely on any of the tools, because scripting is what it is called. So it's basically a code written mostly in Bash or Python to automate something. For example, we could write a Bash script to update software packages in a Linux environment, or we could have a Bash script to, say, back up something on your local machine. So, and also we can automate the execution of these scripts with cron jobs, scheduled jobs. So if you don't know about these, the cron jobs, so consider it as a timer used for scheduling tasks that needs to be executed in the future. For example, you say, please take a backup of this file every day at 1 p.m. or whatever the time you want to take the backup. So cron job will do it for you once you set up it properly. So don't worry if you don't know about anything on scripting yet. There's a planned session on scripting, and you can attend. Not today, actually. It is on another day. You will be notified by the community. Okay, great. So I hope you got some kind of an understanding on these tools. Yes, I know it wasn't a very deep explanation, but I hope you got the gist of it. You're always welcome to read about these tools and try these tools. So our next slide is the containerization. So in this slide, in this topic, actually, we thought of touching the high-level overview of what containerization is. So this is also a very big topic, but for the sake of the time and this session, we will quickly go through what this is and how we can leverage this as someone who is in the IT domain. So if you go back a few years ago, containerization has been a very old technology, but it wasn't widely used back then. As I remember, it was back in 2008. Yeah, it should be 2008 that the Linux kernel introduced the C groups, or what you call the control groups, that basically paved the way to all the content technologies that we see today. So before talking about the containerization and its relevant aspects, let's sneak peek into the life we had before the containerization, so we can understand how important it is to have a containerization as a solution for solving lots of problems that we have today. So yeah, so we all know the famous catchphrase used by the developers: "It works on my computer." So whatever the software component that they have written, it works perfectly fine on their machines. But the problem arises when they start to share their code with other developers or even the operations engineers. So we know that we have this trending culture called the DevOps, which is not a role actually, but rather a mindset, or we can call it a culture. So before the DevOps, we had these two separate teams as developers and operations. So developers are responsible for developing the applications. writing the code and doing the test and all. So operation engineers, on the other hand, they are responsible for deploying those applications in some kind of a platform, making it available to the end users. So this is where the conflict occurred, and they started to pointing fingers at each other. So because whatever code that worked perfectly fine on the developer machines, they now starts to break when the operation engineers try to deploy the same application on the hosted environment. So it might be some dependencies that are not properly installed, or there was always a version mismatch, or some libraries or frameworks are missing. So whatever it is, they took a very considerable amount of time to fix these issues and deliver the product. So this made the shipping of the product less frequent, taking a longer time. And therefore, to overcome this consistency issue with the software packages, libraries, frameworks, and whatnot, containerization actually came in handy and came for the help. So containerization is the process of packaging together software codes with all its needed components, as I mentioned, like libraries, frameworks, and other dependencies, so that they are isolated in their own container. So this container has the minimum configurations to run the application anywhere. So it has the bare minimum configurations to run the application, nothing less, nothing more. For example, if you take a very simple Node.js application, you only need a compatible Node.js version and any of the dependencies in the package.json. So that's all you need, more or less. So with containerization, we package everything together. Actually, more importantly, it is really consistent. No one has to install any packages, any specific versions of those packages, any dependencies. They don't have to uninstall whatever the version that they have on their local machines and install the compatible version. They don't have to do anything, because everything that you need to run on the application is bundled into a single entity. So only requirement is to have a container runtime environment, which we'll talk about in the next few slides. So I hope you get some understanding on the containerization and how it helps the developers and operation engineers in the long run. So in the next slide, these are some advantages of the containerization. As I mentioned earlier, the containers are really very lightweight, fast, isolated environments, limiting around 100 megabytes tops compared to the virtual machines that we have. And also the application dependencies, libraries, binaries, and those configuration files, they actually bundle into the container. This is making things really easy because they have the most minimalistic configurations to run the application. As I mentioned, there's nothing less, nothing more. We have only the configurations that we need to run the application itself. And this actually, because of this lightweight nature, what happens is it actually takes a small amount of memory and CPU. So the resource utilization is really low. Because of that, it decreases the operation and the development cost. And it also helps to, because of the portability of the containerization, it always helps to shift the changes faster. When I say shift, it means like deploying the changes or deploying the changes to the production. So these are some advantages of the containerization. In the next few slides, we are talking about the Docker. So when we talk about the containerization, we can't possibly omit the word Docker, because Docker is basically a container runtime engine. What is a container runtime engine? So a container runtime engine is a software that can run containers on a host machine. So there are the container runtime engines such as Containerd, Rocket, and LXD, like that. But Docker has become the de facto standard. Like, everyone is using that. It is really widely used, super famous. So it is the de facto standard. So in the next few slides, I will introduce you to the Docker and few other things related to it. So what is Docker? Yeah, as I mentioned, it's a container runtime environment engine. So Docker is an open source platform that actually enables developers to build, deploy, run, and also update and manage the containers. Just like I mentioned earlier, these containers allow developers to package an application with everything it needs, and then we can ship that package as a whole. And some features of the Docker actually. So easy and faster configuration. So because everything is defined in a file called Docker file. So Docker file is like the, we will talk about in the latter of this session. So it is like the blueprint to the Docker itself. So, and it contains, this Docker file contains what it needs to be installed, what needs to be present. So now we have actually official Docker images available for almost every tool that we use, and you don't have to write things from scratch. So it's really easy and fast to configure and run a container. Within a few seconds of time, you can actually run a container and get it up and running. So, and the other thing is the application isolation. So it provides an isolated environment separate from other containers with the minimum set of configurations you need to run your application. So it's a very isolated, segregated environment that has its own network namespaces and all the other separated resources. And also the security management. Since it is isolated and segregated, there's a less attack surface, and we can actually limit the access to the containers with different constraints. And also we have the high productivity and the high scalability. So Docker containers can be shipped frequently in a less amount of time with fast, even with the fastly changing modifications, and can be scalable as much as possible because of its lightweight nature, and because of its less resource utilization, all those things, and because of that, it's really highly productive and scalable. And also it is infrastructure independent. That means you can run it anywhere. So yeah, so when you talk about the Docker, we really can't, as I mentioned, we can't rule out talking about the Docker file, because it's basically the blueprint to the Docker image. A Docker file is basically a text document that contains all the commands that helps to assemble an image. And so Docker file enables the greater flexibility and portability for the applications. So if you need to share your application with anyone, you can basically share the Docker file with the source files. So that can be run on on premises, in public or private clouds, or even in bare metals. You just have to share the Docker file and any other resource files that it is consuming. So Docker file has these lines called the instructions, and each instruction you see here corresponds to a layer. So when the image is built, each instruction will be built on top of its previous instruction, which is a layer. So once the image is built, the newly created Docker image basically consists of all the layers. So we call it the layered architecture. It actually it is called the layered architecture because every instruction, when it executes, it creates a new layer on top of the previous one. So if you look at this Docker file, each instruction on the Docker file is executed and results in a new layer on top of the previous layer. And more instructions you have in the Docker file, more layers in resulting image. So more layers in the image, that means bigger the image size and complexity. So with the Docker file, we can create the Docker images. So what's the Docker image? A Docker image is, again, nothing but a read-only template that contains a set of instructions that we have written on the Docker file for creating the Docker container. And that gives that begs the question, what's the Docker container actually? Docker container is a runtime instance of the Docker image. That means any Docker image in the running state is called the Docker container. So let's quickly go through this the lines in the Docker file. So we have the from. So almost every Docker file you will come across will start with the from instruction. So this instruction will set the base image for the Docker file. So in here we have the Python 3.7. So which means like every instruction that follows, that happens after that, applies to this base image. And also other one is the working directory or work dir. So this is basically defines the working directory of a Docker container at a given time. So basically any command that you run, like we have other Docker commands such as run, cmd, add, copy, or entry point. All these commands will be executed in the specified working directory. And also then in here, we are actually creating a working directory called /app. And then we have the copy command, which we are, copying something from a source to the destination. So what happens here is the copy instruction, it copies a folder or a file from your local machine to the Docker image. So when the Docker image is up and running, you will see these folders in the image as well. So, and we have then the run. So this instruction does what it says. So in here, we are using actually pip3 install Flask, which is a dependency for the Python application. So so this is what this instruction does is it runs the command, or more specifically, it executes a specific command. So it is possible to perform multiple commands using multiple lines with the run command, but the best practice is to combine as many commands in one line. So anything, if you want to install any software packages, any dependencies, or maybe like apt update, this is where actually you run it. And that's another command, the instruction called the expose. So expose instruction informs the Docker that the container listens on a specific network port and at the runtime. So this is actually a TCP port. By default, it's TCP. It can also be UDP as well. But default, it is TCP. It is going to open up a new port on the container itself. And so it's going to expose within the container. So anyone, if we log into the container itself, we can actually access the application by hitting that particular port with the localhost. So entry point, this is the other one, the entry point instruction of a Docker file. So this is actually looks similar to the CMD instruction. I mean, that's another one called CMD in the last the bottom one, very bottom one. So this entry point, it specifies the default command to execute at a runtime. This probably, in most cases, this could be a script file, or this could be a binary file. So if you want to specify a command that will run once the container starts, I mean, if you need to run something only one time when the container starts, and you don't want the users to override it, use the entry point. So in our case, it's a Python binary we are executing, and we don't want to override it as it is a constant and doesn't change. And the CMD, this is the CMD instruction, which sets the default command, which will be executed when you run the Docker image without specifying the command. So in here, we actually, if we combine those two instructions together, it is basically like Python server.py, which is running the Python application, just like we run it on the local machine. So, so these are just high-level overview of all these concepts, because we can't touch everything within this limited amount of time. So I believe we now can go for the demo session. So we will be covering a few points in this demo, which is a very short demonstration on scripting and how we can do things easily. And the other simple demo is on the Docker itself. So let me share my screen. Just give me 1 second. I hope you can see my screen. Shifan, can you verify? Or someone?
Yes, yeah, we can see your screen. It's visible right now.
Okay, great. So let me just do a quick demo on the scripting. So basically, what I want to do is, so we have this backup me.txt file, which is really a demo file that I created for the for this demonstration. So I want to back up this text file every time. I mean, every 5 seconds. So if I do it manually, what I would do is I would have to do if I do it manually, what I actually have to do is we have to copy this backup.txt file to something like this. So we have the 2 files. And again, if I want to do the same thing, we can do the same thing manually. So this is actually taking a lot of amount of time, and also this is a manual work. So this is with a very simple and very but yet more powerful automation script. Actually, we can automate these kind of things. So for example, this is a very simple automation script which is running a while loop. So just to give you some understanding on what I am doing here. So I'm just getting the current date time to a variable, and I'm going to actually nothing but executing a simple copy command to back up this particular file to a new file. So, and it's going to sleep in 5 seconds. So this is a very, very, very simple and a minimalistic example. So let me get rid of these files. So what I'm going to do is I'm going to run this automation script. So what happens is actually it is going to create a new backup file every 5 seconds. So this is a very, very, very simple example just to give you some idea on how powerful this automation is and what we can do with this. So yeah, this is a very simple actual demo. And also we have another demo on the Docker, because I believe going forward in the in the series, you might need this instructions, you might need this hands-on to do the corrections that given by the community itself. So in here we have actually 3 files. We have a Docker file, the same Docker file that I showed you in the slide itself, and we have a server.py. So this server.py is a Python file, which is a very, very which uses the Flask library, which is a very simple Flask HTTP server. So what it does is when it is run, it is going to, when I actually access the browser with the local host / is going to give me this message. It's a very simple message. So we are going to Dockerize this. So what happens is, just like I mentioned, we have a base image. Since we are using a Python script, the base image is the Python 3.7 or whatever the image that you want to specify here. So so this is really the how powerful the Docker is, because in here actually we can specify what Python version you need. So if your application is actually running compatible to run only on the Python 2 point something or 2, so this is where actually you can specify the Python version. So this is the base image, and this is this Python 3.7 image is actually pulled by the Docker repository. And so yeah, we specify the base image, and we, as I mentioned, this is going to set up the working directory. So it's actually a good practice to do everything in a working directory, because all these commands that we execute, all these instructions that we execute, it will be executed on this working directory. And also, what we're doing is we copy the server.py to app directory. So this is the server file. What this does is it copy. So normally the copy command is like it actually retrieves 2 arguments, which is the source file and the destination file. So in here we are copy server.py, which is in the same directory. And we are going to actually copy it to the /app. Actually, we can use the same thing like dot, because if we set up the working directory as /app, that means we are already within that directory. So everything that we copy, every file that we copy from the local to this dot means actually the current working directory, which is the /app. But let's keep it like that. Keep it before. So it is going to copy the server.py to the working directory, and this is where we install the dependency actually. So we are running, executing the run instruction, which is going to install the Flask library, which is the pip3 library dependency, and this is actually so if we do it like in a local environment, we probably
Excuse
have
me.
a lot of
I think the text size of your code editor is not big enough. Could you try making it bigger for the viewers?
Okay, sure. Oh,
Both
sorry
on
guys,
your
I was
terminal
actually
and your editor. Yes, sir.
okay. Is it now visible?
Yes, I think this is good enough.
Okay, great. Okay, so we have we are actually installing the dependency, which is the Flask dependency, and this is where actually we expose the container. So this is going to create a expose the container on port 5000. It's a TCP port, and just like I mentioned, this is the entry point, which is the Python Python binary, and CMD, which is going to execute this server.py, which is we just created, we just copied in this line 7. So this entry point and command line, this command instruction is actually just like this. It's like we execute Python server.py in a local environment. It's nothing fancy. So what I'm going to do is I'm going to build this Docker image. So every time, I mean, if we have a Docker file, first we have to do is actually, if we want to run a container, we have to build the image. And then once the image is built, I mentioned about the layered architecture. It is going to, execute one instruction at a time, and it is going to create each instruction as a new layer on top of the previous one. So the command is actually docker build and -t actually for tag. So we tag we are going to tag this image. Let's say test. And actually, when it comes to Docker, we have this tagging mechanism, which is like if this is the, I mean, if we have multiple versions of the same application, we can have separate Docker images with different tags, just like the version controlling tags. We can actually tag the image. So that's how the segregation happens with the versions. So let's say this is our version 1, and we give a name and actually give it a tag, and then we specify the Docker file path. So if I do this, I am actually in the same directory as the Docker file. So what I can do is docker build -t test 1, and either I can actually give the absolute path, the same path like this, where the Docker file resides, or I can actually give the dot. So in Linux, the dot means the current working directory. Whatever the content that we have in the current working directory, please refer to the Docker file in that directory. So that's what it does. And if I do this, it is going to build the image. So actually, this is going to build everything, like as I mentioned, like layer by layer, by instruction by instruction. You can actually see the flow of the Docker build there. And once the image is built, successfully built, we can actually view the image with the Docker images. So we have this test one, and with the tag. So if you have any, if you wonder what if we didn't tag the image, what it does is actually it is going to be the latest version. For example, if I run the same command without any specifying any tags, this is actually going to build the image with the tag latest. So that is why it is really important to tag the images as a best practice, so you can differentiate between the images. So this test is the latest tag, which I didn't tag. So this is the one I tagged. And once the image is built, we can actually run it. And so yeah, So let me show you something. If I actually run the content, run this image like this, it's going to create the container itself. So if I do a docker ps, it's going to, yeah, it is showing the container is running. So the problem is it's in port 5000. So if I do this, try to access this port, it's not connecting. It's not reaching the container. Why? This port is actually, we haven't exposed the port. Even though in the Docker file itself, we use the expose instruction, it is actually exposed within the container itself. As I mentioned, if you remember, I told you that when we create a container, it is going to create an isolated environment. And actually it is isolated from the host machine, which is, this is my computer, host machine admin, and we have a running Docker container, but this port is only exposed in the container itself, within the container itself, not the host machine. So even though we expose it, we really can't access it. So I will do one thing just to show you. If I execute into this Docker container, I hope the bash is there. Yeah. So I'm within the container itself. So you can see I'm actually in the working directory, just like I mentioned in the Docker file. And within this directory, we have the server.py, which is the same file that we copied. And let me do, okay, I think we don't have the netstat. Okay, so what I did was actually there's this tool called the netstat tool, that net tools, that actually we can see the opening ports in a Linux environment. So if I do netstat plt and show me any listening ports, so you see now the port 5000 is exposed within the container. So just remember that we are within the container. I'm not in my local machine. I am inside the Docker container. And if I do an netstat pltn, which is a command that to show any listening active ports, it is going to show me, okay, there's a one TCP connection with the local host with the port 5000. So this is actually, I think this is accessible within the container itself. If I do a 5000, I think I should give the HTTP. Yeah, I'm getting actually 200. So within the container, we can access this Python application, and which is actually not the correct way. This is not actually the way that we want it, right? We want to access it locally. So what we have to do is we have to expose that particular port within the container to the host machine. So this is called the port mapping. So let me just run the container from scratch again. Let me stop this container and probably remove it. So we don't have any containers up and running. And I will actually run the same container, but this time I'm giving -p flag. So this is to specify the port mapping. So this port mapping actually requires two arguments. So which one is the port that you want to expose this on the host machine, which is my machine, and the port you want to bind that to or map to the container. So container is running on port 5000. Let's say we want to expose this on the host machine on port 8080 and map that to container. So basically it's like expose this container on the host machine on the port 8080, and whatever the request come into this 8080, please map it to the 5000 within the container. So if I do that, it is going to run the container itself. Okay, let me check what is happening. One second. Okay, this is not the correct way. Yeah, actually, I think I should give it like this. 8080, expose the port 8080 on the local machine and map it to the port 5000 of the container of the image, which is the test one image. So we have running container, which is even in the, if you do a Docker PS, in the output itself, you can see this local host of the host machine, which is on port 8080 mapping to the container port 5000. So if I go here and if I do 8080 on the local host, it is going to give me the, actually we can access the container, the application running on the container. So this is actually the port mapping, and that is how we actually build the Docker image and how we run the Docker container and how we can expose it to the outside so we can access the content within the that Docker image, Docker container. And so, yeah, this is basically regarding the Docker build and, you know, exposing the content within the Docker container. So I have another one, which is regarding the Docker volumes. So basically what happens is, let me do something like this. Let me kill and remove this Docker container. So we don't have anything running at the moment. Okay, this is the other one, the one that failed. And so the Docker volumes, the reason actually we use the Docker volumes is, just to give you some overview of the Docker volumes, say that we have some applications that we need to. Okay, before going that, I will tell you the nature of the containers. So everything that actually we do within the containers, when the container goes down, it is not persisted at all, because all the data within the container will be died when the container is stopped. So we don't have any access to any of the files. So to overcome this, actually we can create the volumes which will persist the data even after the container is died. So that's basically the theory, what is happening behind the containers within the when we want to persist the data. So I have a few commands here that actually tried that the day. So we are going to run a Nginx, simple Nginx web server. So let me pull the image. So and another thing, if you do a Docker pull with whatever the image that you want to image you want to pull, this is actually going to pull from the Docker repository, which is this one. So we have, you know, this is the Nginx image. So whenever you do a Docker pull Nginx, first it try to it actually try to pull the image. Actually, what happens is, when you do a Docker pull, first it tries and check if we have that image locally. So if that image is not locally available, in my case it is available. If it is not available, it is going to actually pull from this Docker public repository. So now, since I have the Nginx image, it wouldn't pull the image from the Docker Hub. Instead, it will reuse the same image that I have on the local machine. Yeah. So, and so now I have the Nginx, and I'm going to run a simple Docker container from the Nginx. So we have a container. Okay, it is running. That's good. So I can access this container on port 8080. So I'm going to access this on the localhost. Yeah, it works fine. So this is the welcome page of the Nginx itself. And what I'm going to do is I'm going to execute into this container. I can actually give the name of the container and the interpreter. So I am within the Docker container. So what I'm going to do is the file that you see here, this welcome page, is actually present within this directory within the container. So you see there's a index.html, and if I not sure index vim is available, but okay, it's not. So whatever the index file that we have here, it is this is the same thing actually we see here. So what I'm going to do is I'm going to change this file. So let's say that, okay, this is the HTML file that we need to modify according to our needs. So I'm going to execute this command. What it basically does is it's going to replace whatever the content within the index HTML with this content. I changed this file while running the container. Yeah. If I cat the index again, so you see, earlier we had this index HTML file, and now it is being changed to something like this. So if I refresh this page, so it is going to reflect the content. So let's say I run another container. And this time let's map the port. Since the first Nginx container is running on port 8080, 8081, let's try to have it on port 8082. So we have two containers running. So if I go there, so basically it is not actually what I'm saying is it is not reflected, which is obvious because I want to see this content, but it is not showing here because it's a new container, and the data is not shared within the containers. And if I stop this container, Nginx container 1, the earlier one with the changes I have, and if I'm going to start my container again, so just think of it as like the container is deleted and restarted again. So this is I have to stop and remove it. 1 second. If I run the same container again, you can see whatever the changes I did, it is not persisted anymore. So this is a really big problem. Like if we have any critical data that we need to persist, that we need to keep any longer, even after the container dies. So this is not the work. I mean, this is not going to work because, you see every time the container is stopped or killed and restarted, the changes are not there. Actually, when the container is stopped and restarted, change is going to be persisted. But when a container is exited, like removed, and again, if it starts again, back again, the changes will not be reflected. So what we can do is actually, there's this concept called the Docker volumes. What we can do is, let me first stop all these containers. Now I believe we don't have any running containers. Okay. Let me remove this. Great. So, and after that, what I'm going to do is I'm going to create a volume. So I think I already have a volume created. So with this Docker volume create Nginx, this is actually going to create a volume. It's like a directory. I think it is in var lib. Let me check. Actually, I can. That's an already created volume. I'm going to use the same one. So this is actually going to create a directory within this directory, which has basically where the Docker volumes are created. And what I'm going to do is there's this other command we can use to run the same container that we used that we actually ran earlier. Let me explain this. So this is going to actually Docker run. So -d is like run this in background. Otherwise, it is going to run in the terminal itself without running on the background. And we provide the name, and we mount this particular volume, which is the Nginx volume that we created, and we are going to mount that particular volume into the destination, which is user share Nginx HTML. So this is the same. This is the directory that we had the index.html. If you remember that we did some changes. So what I'm going to do is I'm going to mount this particular Nginx volume in my local machine to the user share Nginx HTML directory. That is going to be within the container once the container is created. And I'm going to expose the same container on the port 8080. And I'm going to use the same image, Nginx. So we have running container. So what I'm going to do is, so if I access this, okay, because I already created the volume itself before. Let me create a new volume. So that's why it is reflecting the changes, because I already created this volume and there were some changes there. Let me create a volume from scratch. Okay, so I'm going to create a volume, Nginx volume 2. So we have, if we do volume ls, so volume ls, we have Nginx volume 2. So we can actually Docker inspect volume name. So it give you some kind of an overview of what type of driver it is using, which is a local driver in my local computer, and it's going to it's actually existing this location in my local computer. And what I'm going to do is I'm going to run the same command that I ran earlier, but this time with the new image, new volume that I created. So it's the same thing that I'm going to mount my local Nginx volume 2 to this particular path of the container that is going to be created. So we have this one. Yeah, great. So if I do that, yes, we get the welcome to Nginx welcome page. And after that, what I'm going to do is I'm going to execute into this container. And I'm going to, it's going to be user share Nginx HTML. This is where our index HTML resides. So if I do a cat, it's the same thing that we see in this web page. I'm going to echo is the volume, is the data. Let me do something like data persisted. And I'm going to echo that particular the lines to the index.html. So it will be modified, and we have the modified index.html. So if I now refresh it, yeah, we get the modifications that we did. Say that we want to persist this index.html file, because every time the container dies and it comes back, we don't need to execute go into the container itself, and we don't need to modify this index.html file. So what we can do is actually, just like we did, we mounted this Nginx volume to this directory. So we have this directory has been mounted to Nginx volume 2 of my local machine. So what I'm going to do is I'm going to stop this container, and I'm going to kill this. I think I can use the docker kill command. So this is going to, okay, it's still there. Okay, docker remove. So I'm going to remove it completely. So we don't have any Docker containers running. So the last time we did this, the changes were not persisted. It was all came back to the default landing page. So now what I'm going to do is I'm going to create another container, but this time we are actually going to mount the same volume that we mounted to the first volume. So this is, let's say it is running on port 8082, Nginx container 2. So if I do a docker ps, we have the Nginx container 2. And if so this is the earlier container. So if I refresh this, yeah, see the data has been persisted. So this is a very simplistic and minimalistic demo on how we can persist and preserve the data between the containers. So in the Docker's perspective. So I think that's all for this demo. If you have any questions, please feel free to ask. Okay, we have. So, are there any GUI tools for Docker? So Docker for the Windows and the Mac OS, we have the Docker desktop, which is this, if you can see it. For the Linux, we don't have a GUI. The last time I checked. So for the Mac OS and the Windows machines, we have this Docker desktop, which has everything that we see in the terminal. So can exposing Docker pods harm my PC? So exposing Docker pods, actually, it depends. If you're actually using it for any development environments, just for testing purposes, that's totally fine. But this is, I believe it is not harmful as long as you don't do anything. I mean, it is not exposed to the outside world and no one can reach you. Oh, okay. I think, okay. Docker is still, okay. Yeah, great. Okay. For Docker entry point, actually, that I haven't tried. So entry point, I believe we can. It accepts an array of things. Yes. So if you ask it like that, I mean, this is actually a array of things. So for example, actually, we can have some other commands like this, if that's what you meant. So what tools are better to start with in automation? So so it depends on what you're going to achieve. I mean, if you are like a QA, that's a different domain that you can actually look into those tools, such as the Selenium and other testing tools that Sonar Cloud. For the I think it's for the configuration scanning tools, like the code, any bug smells, code smells there, and it actually depends on what path you want to choose. In the DevOps, there's a set of automation tools that you can follow, and also for a start, if you ask this question in the DevOps perspective, I recommend you to follow the DevOps roadmap. So there's this a very nice roadmap that published by the CNCF that how a beginner should follow. If you want to be a DevOps engineer or to work in a DevOps culture, so this is the roadmap that you can follow. That's a very nice guideline. I think, yeah. So we have, I think I probably will share it later. So we have this very nice roadmap with all the tools that you can start with. So can we have a cron job about this similar to Lambda functions? yes, we can have actually cron jobs on AWS similar to the Lambda functions. So Lambda functions are so cron job is Linux. Cron job. The name itself is a Linux binary that you can write the cron jobs to automate something or schedule something to do some automation tasks. And yes, on similar AWS, if you're running this, if you have S2 instance, you can do the same thing if it is running Linux. So does that answer your question? And the way I actually that when I mentioned about the experience that I had with the Lambda. So in Lambda, okay, what is this? Is that the same work as cron jobs? Yeah, actually that's called the AWS Event Bridge. So we can in the Event Bridge we can create a what do you call the expression, scheduled expression, and which we can invoke a Lambda function. So it is similar to this. The actually the names are different, but the same context and same experience. Yeah, there's a service called AWS Event Bridge that we can create scheduled expressions that will trigger a Lambda function.
Okay, I think we have come to the end of session with the QA. So thank you, Mr. Jananath, for that informative and wonderful session on the introduction to automation as well as Docker usage. I hope this session was useful to all our viewers and participants. So we will now proceed to the Q&A part of the competition. So if there's any questions directed towards the competition, you can ask them in our comment section as well. We will give a few minutes till we have a few questions related to the competition. I think we have a question related to automate the performance usage, Mr. Jana.
Okay, so okay, so what about the memory performance sessions container compared to the containerless deployment? So by the containerless deployment, did you mean like a virtual machine or something? If that is the one, yes. I mean the usage when it compares to the when we're running, for example, a virtual machine, there's a very huge difference. Like because the containers are very lightweight components that only takes less CPU and memory resources compared to, because I mean if you see the architecture in a virtual machine, we have the guest OS of the operating system, which when we run a virtual machine, what happens is it's actually have another VM on top of that. So just like it is like we have a VM on top of another VM, which is same as resource consumption as the host VM. So, but compared to the containers, containers are actually which is running on top of the guest OS. It doesn't have any virtualization, and because of that, the resource usage is really low compared to when we spin up a virtual machine. So regarding the online resources, I actually followed some Udemy courses and also and some YouTube videos. That's how I started. And then also my first experience with these tools is because of my internship I did at Pearson. Actually, I was in the cloud operations team, and there was this big stack of technologies that we used back then. I think they are now even using that. So yeah, that is kind of the first experience that I had with these technologies. and that paved me to work and research more and get to know more about this technology. So I recommend that you guys can actually follow the roadmap, the DevOps roadmap, if you want to learn more about this DevOps culture. And then the internet is a in internet there are many resources, and it's a free university. You can leverage on these resources actually.
Okay, I think that's the end of the questions. Thank you so much for your time, Ms. Jananath, and the academic advisors and esteemed guests who made this session a success. We have one more. Okay, so this brings an end to our session today. So I wish you all good luck with the competition. Know that the stream will also be available on our channel for future references. And this is the first of mentoring sessions that we are going to host. So stay tuned for updates on our social media and our official WhatsApp groups. Till then, take care and have a good night.